The flux lines look stable, but the gap tolerance is slightly off nominal here.
Check the density readings on this section.
The ablation layer needs to withstand 2,500 degrees Celsius.
The shear stress on the avcoat during re-entry is critical.
Check the thermal readings on Sector 4.
Acknowledged. The automated polish sequence is stable.
Zooming in on the waveform, the amplitude here looks consistent with the baseline.
Agreed. No indications of delamination on this segment.
We are approaching the target acceleration.
Data looks nominal across the array.
This thermal data is showing significant deviation.
Zoom in on the Artemis 6-point array.
The localized heating is exceeding the safety limits.
These are the critical thermal protection system tiles for the Orion capsule. Each one is meticulously inspected before integration.
This close-up inspection guarantees that the heat shield can withstand the extreme temperatures of re-entry.
We need to verify the Pinex material tolerances here.
The thermal gradient suggests we might see ablation at this joint.
The leading edge is showing higher flux than predicted.
Confirmed. The ablation rate is accelerating at that junction. The microstructure here at the bonding line is exceptional.
Okay. Confirms the data from the ArcJet testing. The recession rate is stable.
Roger that. Control. Panel is entering the chamber.
Trajectory holding steady. Each segment of the Artemis Heat Shield undergoes rigorous automated inspection before flight.
We have full engagement on the thermal sensors.
Noted. Keep monitoring the degradation rate.
Look at the thermal gradient right there.
It's failing much faster than the model predicted. The ablation rate is critical.
Status check on the starboard array.
Cleared for integration, lead. The thermal readings are nominal.
As you can see on the thermal map, the pica ablation is slightly higher than modeled during re-entry.
Yes, the localized heating near the apex is a...
check the magnification on this section right here. Yeah, I see the stress fracture. Let's tag that for further review.
We're seeing unexpected variance right here on the T-tip.
Confirmed. The T9 reading is anomalous.
The spike at 1500 Celsius is holding steady.
Yes, but look at the leading edge. We're exceeding predicted flux rates by 10%.
The thermal gradient is spiking at the apex.
I'm increasing the ablation rate. Keep monitoring the pressure.
Watch the trajectory on that next tile. The alignment is critical.
Confirmed. Adjusting the parameters now.
The ablation layer seems thinner at this joint.
Agreed. The telemetry confirms the higher heat flux.
Running a new simulation based on that data.
Reading at 42.5 millimeters. Confirmed. Data logged.
The thermal gradient is stabilizing.
Confirmed. Data looks good at T plus 3 minutes.
Here in the assembly bay, the massive Artemis Heat Shield, the largest of its kind ever built, is carefully maneuvered into position.
The temperature on the leading edge is exceeding predictions.
Check the flow rate. We might have an instability.
RTV readings are holding steady for now.
We are exceeding the peak reentry parameters. The shield is performing nominally.
Copy that. Logging the data now.
Reading nominal at 45 degrees, torque checks out.
Confirmed. Sensor alignment complete.
Test sequence ready to initiate.
We're seeing an anomaly in the convective heating results here. Run a level 2 diagnostic on that segment.
Running the diagnostic now, the data should clarify the discrepancy.
The Artemis Heat Shield undergoes rigorous testing, simulating the intense vibrations of launch and re-entry.
We are seeing some slight ablation near the center point.
Keep the pressure steady. We are approaching peak flux.
The Artemis Heat Shield tiles must withstand extreme temperatures, glowing bright orange as they reach peak heat during the cycling test.
Core temperature holding steady at 2500.
Roger that. R value is nominal.
We have a spike at sensor array 7. Core temps are rising too fast.
Initiating abort sequence thermal bypass. Rerouting coolant now.
Increasing power by 5%.
Acknowledged. We are holding stable at T plus 300.
Check the telemetry on placement accuracy for Sector 3.
Looks nominal. We are within tolerance. I've identified the microfracture at grid coordinate 7.
Noted. Scan the surrounding area for propagation.
The temperature on Sector 4 is exceeding the predicted limits.
We are seeing the same spike on the secondary sensors. We need to initiate the cooling sequence.
Reading is stable at 1.25 inches.
Confirmed. Logging data point 4.
Look at the thermal bloom on Section 4. It's hotter than expected.
We're still within tolerance, but keep a close eye on the subsurface sensors.
This is the largest heat shield ever constructed, now being carefully maneuvered into position for the Artemis mission.
We're seeing peak thermal loads right here at the apex. Check the TPS degradation.
Copy that. Rerouting the flow analysis now. The strain is stabilizing.
Green light on this section. Copy that. Values are nominal across the board.
Temperatures are spiking near the center.
We're showing peak flux at T plus 60 seconds. The sensors on the starboard side are holding steady.
Good.
Maintain current levels and watch for delamination.
We need to verify the alignment on sensor Fortin before we proceed with the thermal cycle.
I'm getting a slight variance here.
The thermal gradient here exceeds the predicted threshold at peak atmospheric reentry.
Rerunning the ablation model with the new coefficient now.
We are at peak load now. Check the forward accelerometers.
Channel 12 is spiking slightly, but holding steady.
Check the thermal readings on sector gamma.
Holding steady at nominal, 42% power.
Check the flux reading on panel 7.
Confirmed. Data logged. The peak intensity is stable.
Temperatures are nominal across the array.
Copy that.
Increasing the plasma flow rate by 5%.
Artemis panel lift initiated. Trajectory stable.
Copy that. Proceeding to alignment sequence. We are green for integrator. Ablation rate is spiking at Sector 4. We're exceeding the limits. I'm pulling the power back now. Watch the temperature curve.
The alignment on sector 4 looks good.
We're within tolerance, but keep an eye on the thermal gradient during curing.
Agreed.
This spike at the leading edge is concerning. We need to verify the thermal conductivity.
The model predicted fluctuation, but not this magnitude. Let's rerun the analysis.
The expansion rate at T+15 is exceeding predictions.
Check the boundary layer readings again.
Alignment holding steady at point 02.
Confirmed, you are clear to proceed with the final sequence.
The ablation rate is spiking at the apex. We need to stabilize the plasma flow.
Copy that. Adjusting the frequency now. Monitor the boundary layer transition.
We have a spike at sensor array 7. The ablation rate is increasing rapidly.
Acknowledge. Reroute coolant and maintain current parameters.
Ensure the torque is precisely 75 inch-pounds on this array. The thermal gradient is critical here.
75, confirmed. Moving to the next sensor.
The thermal gradient at the stagnation point is exceeding the predicted threshold.
Yes, we are seeing some unexpected ablation here at the 1500 Kelvin mark.
The x-axis oscillation looks stable within the parameters.
Agreed. We maintain structural integrity throughout the cycle.
Are the thermocouples holding steady at this flux point?
Yes, TLI is nominal across the board.
As the plasma hits the tiles, the temperature rapidly climbs to 2,500 degrees Fahrenheit. Then we introduce the cryoshock for the cycling test.
The ablation rate is spiking at the apex.
Copy that. Logging the thermal gradient now.
The ablation rate is higher than predicted right here.
Yes, the thermal gradient is spiking at the apex. We need to maintain this flux level. Clearances look good on my side.
Copy that. Proceeding with the rotation. The thermal gradient is stabilizing at 1500 Kelvin.
Confirmed. Adjusting the power flow to the upper bank now.
Copy that. Watch the ablation rate.
The sensor reading here is fluctuating slightly.
Yeah, it's within the expected parameters for this sequence. Monitor the next placement.
Okay, I'm seeing a delamination here at H12.
Confirmed. The depth measurement is slightly off nominal. Mark it for review.
The ablation rate at this section is exceeding predictions.
The SXX.Y TF sensor shows a 20% spike during re-entry.
We are approaching peak flux. Monitor the leading edge.
Reading nominal values on Zone 3.
Telemetry is green.
Final inspection complete. All tiles accounted for.
Roger that. AGV is green for pickup.
We are approaching peak temperature on sensor array B. Ablation looks nominal. Maintain current power levels.
This temperature gradient here, just above the pica coating, are we seeing delamination?
Negative, sir. The sensor reading stabilized after the peak aerodynamic pressure.
Understood. The shield held firm.
Tile inspection on sector gamma is complete.
Copy that. We are commencing the final power-up sequence. Scan complete. All parameters nominal.
Confirmed. Ready for sign-off.